So yes, it's very well suited for geographic questions. When it comes to displaying stuff in the web, well, the web is the future of programming still, I think. So a lot of things have moved into the web, and the web is built upon HTML, and HTML has one super first class programming language, and this is JavaScript. So I think it's a very good fit to answer geographic questions when they come to the web with JavaScript.
Welcome to the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Mark Jensen. He is a member of the Openlayers project steering committee. He's also a core committer to the project, and today on the podcast we're going to be talking about a really incredible open source geospatial JavaScript library called Openlayers. So I really hope you enjoy the conversation. Thank you very much to OSGeo for helping make this podcast episode possible. I really appreciate your support. Hey Mark, welcome to the podcast. I appreciate you taking the time to do this interview with me. Today we're going to be talking about Openlayers, and we're going to be talking about JavaScript, and because this is a geospatial podcast, it's got something to do with geospatial. So I think before we get started on Openlayers JavaScript, perhaps you could just let the listeners know how it is that you got involved with the Openlayers project, how you got involved with geospatial.
Yeah, first of all, thanks for having me. My name is Mark. I'm an Openlayers core contributor and member of the project steering committee. Well, how did I start to get involved in geospatial or Openlayers? Well, I studied geography, geology, and urban development, and I had to do an internship at some point in my studies, and I picked a small local GIS company. I met super interesting and inspiring people, and well, this is how I got into it. And I first got into contact with Openlayers, that library that we are going to talk about, probably in 2006 or 7. Well, and then my first contribution to that library was very well received by those people that I only knew from reading internet. And back in the days, it wasn't as easy to contribute as it is today. I got some very encouraging review. I mean, Tim Schaub, who felt like a rock star to me, called it a model contribution, but it was just some small thing. He accepted the patch, which was very cool. Well, and then some other contributor reverted it and removed the code again, which was funny and a bit discouraging. But on second side, it also showed some very high quality standards and open discourse, rethinking stuff that someone else has done. This all felt like a very good thing to work on.
Just out of curiosity, before we dive a little bit deeper into Openlayers, were you a programmer before? Like, did you have some sort of official sort of education in computer programming?
No, I didn't do any formal education in programming or computer science, but I was, I'm self-taught, so to say. So I did homepages during the studies, and I got in contact with all the building blocks also of Openlayers. And in that internship at that GIS company, basically from day on, they would throw something at me with my basic small knowledge, and then I had the time and cool people around me that helped me to get started. But I'm self-taught.
I'm really pleased that you shared that with us, because I think it gives hope to a lot of people that have sort of an aspiration to learn a programming language. It feels like a pretty big mountain to climb, but I mean, if you can do it just by reading the internet, figuring it out, and become a core contributor to something like Openlayers, I think I think it gives a lot of hope for people.
Yeah, and you're totally right. If I can do it, because I'm not at all the smartest person on the planet, then, well, basically a lot of people can do it if you take your time.
Please don't take this as any sort of criticism. That's not
No,
where I was going with that.
no.
But I just think that, sometimes it feels like it's out of reach. So some programming languages, because the technical standard is very high. When I talk to a lot of people involved in the open source world, I mean, some of the things they're doing is simply amazing, and it feels like it would be difficult to get involved.
There are a lot of amazing both people and code out there. I totally agree with that. But once you get to look into the code, it's all just, like text files. You have to play around with it. and then you will be able to contribute somewhere. And I know that there is great code out there, but at least the same amount of bad code is out there, and small things that need enhancements and things that basically everybody can do as soon as they, like get the basics done.
I think too, there's a lot to be said for a fresh perspective as well. So we've jumped in a little bit deep here, perhaps. Could we back up a few steps and maybe could you give us a brief overview of what JavaScript is?
Yeah, so JavaScript is a fully grown up programming language. It runs both on the client, we say. So, for example, when you visit some of these modern websites where you can edit documents, text documents, or spreadsheets on the web, then JavaScript does a lot of the heavy work that helps you, like color cells based on some value and stuff like that. That's something that JavaScript does, but it's also running on pretty much every device that exists. So it's not only running in browsers in the client, it's also running on servers, and it's used by millions of people. It's a very fun language. It has evolved a lot over the last, let's say, decade. It started out as a bit of an experiment, or it has nothing to do with Java except for the name and some syntax. It's derived. It derived from Java. It's a very, very cool language. It's cool to start with. Well, if you have never programmed before, JavaScript is a very good choice to start with, and it's also a very good choice to continue your complete professional future with, because it's also still growing, and there's a lot of people earning their money and solving their problems with JavaScript.
So you mentioned there that it's a client side and a server side. I think a lot of people listening to the podcast will understand that JavaScript, runs in web clients. We're used to seeing it, of course, in something like Openlayers, on these slippy maps on the web, dynamic maps, dynamic websites, that kind of thing. Where might we meet JavaScript apart from in the web browser?
Well, if you want to, excuse me, if you want to see JavaScript apart from on the client, then you'll have to dig a bit deeper. So JavaScript can be used to run on a server to produce dynamic maps. So the thing that usually, if you probably have heard about something called PHP. That's something that's used on many servers to produce dynamic sites, to query databases, and to produce websites that are not statically written once, but that are able to fetch content from somewhere else and then present it to the user. You can do this with PHP, as I mentioned. You can do it with a lot of other languages, and you can also do it with JavaScript. And then in that case, JavaScript is running on some other computer in the internet. It's not running on your machine, basically, in that case. It can also be used to, well, coming back to the topic, this geospatial thing, to solve geospatial problems on the server, so it can make use of the resources that are on that big machines that are called servers.
The topic of the conversation today is Openlayers, and I think you've done a great job of sort of giving us a brief understanding of what JavaScript is, where we might find it, and I think we'll probably go into a few more details later on. But maybe now we could start on Openlayers. What is Openlayers?
Well, of course, I was prepared that you will ask me that, so I looked it up on the website to give the most concise definition. So a high-performance feature-packed library for all your mapping needs. That's what we write on our homepage, and that's what it is. So it's an open-source JavaScript library that helps its users to create stunning and fast and feature-rich maps, and you can put them on any web page.
Okay, so if we think about it in terms of, break it down into two sides here, and think about it in terms of visualization, so that platform where we perhaps combine a whole bunch of different services, bits of data, and visualize them, and perhaps we can look at it in terms of any sort of analysis functionality that might be available. Could we start with the visualization piece? What can we do in Openlayers in terms of visualizing data?
That's basically where it all started with Openlayers. So it has this layers in its name. So Openlayers is capable of reading a lot of different data formats that exists that have some geospatial part. So it starts with some simple GeoJSON file that contains some vector data, probably some points that have some attributes. It can also read and display KML, something that you may have heard, or GML, that's more specific formats now. But it can also fetch pre-rendered tiles. So, for example, OpenStreetMap produces great tiles of their database, which basically can help you to create a nice background map on your map application. And Openlayers is able to combine all these different sources and stack them on top of each other so that you get a very flexible solution for your mapping need.
So one of the big problems we face with geospatial data is it comes in obviously a lot of different formats, like you mentioned, but it also comes in a lot of different coordinates. Does Openlayers do anything to help us out there in terms of stacking and layering data so things land in the right place?
Oh, yeah, that's an awesome question. So that's one of the parts. So Openlayers shines in many, many parts, and I hope to touch some of them during this interview. So projections and the handling of different projections in Openlayers is outstanding in my perspective. So short, yes. So any data format or any data that you have any geospatial data that you will have some sort of explicit or implicit specification of where on Earth these coordinates are located or how they are to be interpreted. And Openlayers deals with, let's say, 99% of them, and it does so by some other aspect of Openlayers by using the great Proi library, Proi4JS in that case, which helps it to combine different sources from probably different projections, and doesn't only do that for vector data, for which it is easy and also not that big of an achievement. Many libraries do that, but it also does it with raster data. So vector data is just the raw, like coordinates, like you can read it with many things. But with raster data, you basically only get the pixels. So if you have tiles or geospatial raster data in one geographic projection, it used to be very, very hard to combine it with different projected coordinates or data from other sources in the web. And Openlayers has a great way of reprojecting, in case it is needed, raster data and vector data to that projection that you give it. So it's very good at handling different projections, raster or vector data.
So you mentioned that was the Proj library that takes care of that. So when I think about Openlayers, should I be thinking about it as a collection of different JavaScript libraries?
No, I wouldn't call it that way. So Openlayers it shines and has some very strictly defined capabilities. So it can read a lot of formats, and it can present them on top of each other, and that's just the visualization part. It can also give you a lot of ways to interact with that data, something we might come back to later. But it also plays very well with other libraries. And when it comes to projections, not only in the open source world, Proi is basically the de facto standard of doing it. Also in other libraries, it's being used. It just, Proi has specialized on that, and it's very good in doing that. And Openlayers has some basic ways of handling the two most common projections, and everything that's above that, it delegates to the real expert, and that is in our case Proi. This brings me a bit back to the JavaScript thing in general. So that's a very common trend right now, so that small micro modules basically exist that do one thing and do it very, very good. And it's with Openlayers a bit of the same story. So Openlayers is great at combining sources and make you interact with that. Whenever it becomes too hard or too specialized, then there's very probably a very good library that you can use that will help you to fix your specific problem.
Can we stay with that idea of interacting with data just for a second here? So at the moment, we understand that we can visualize lots of different data formats, so we can stream them into this client if we're thinking about Openlayers and running on a web page, for example. Interaction, is this built into the library as well? What kind of interactions can I detect and use?
Yeah, there's a lot of interactions already built into the library. So the most basic ones like zooming in and zooming out on maps. That's of course included. You can also pinch the map, so you rotate it. Like if you're looking at an Openlayers map on your mobile device, you can zoom by pinching, like you are used it from Google Maps or some other provider. There's that. Then there's of course the ways of like editing data. So I already talked about displaying vector data, for example, but it's not Openlayers doesn't stop at displaying it. It also gives you the tools to edit it, for example. So there's ways of, for example, creating new points, digitizing new polygons, rotating existing polygons, so stuff like that. So basically everything that you can do on any map you have seen in the web, you can also do in Openlayers.
You mentioned something interesting there. So if we're working on a mobile device, for example, we can use this pinch function. And I think all of us listening to the podcast will understand how that works. We will have used a map on a mobile device before. But when you're developing this, does Openlayers just sort of detect, okay, I'm running on a mobile device now, therefore this pinch function is available? Because it wouldn't make sense to run on a desktop client, or at least most desktop clients.
Yeah, that's an excellent question. So yes, it does detect whether you're on a mobile phone, but when it comes to that specific thing, it's just that this is probably a bit too detailed and technically, but stop me if it is. So when you put your fingers on the map, then touch events are registered. That's what happens. So your finger touches your display at two places, for example, and this has been standardized not too long ago. And basically, it's quite easy to differentiate whether there were two touches, so two fingers, and whether they are moving now to the outside, so the distance between them gets bigger, or the distance between them gets smaller, or whether they also rotate something. So this is what is happening internally. You said it doesn't make too much sense on a laptop, but there are laptops out there that have touch devices, so that have displays, even bigger ones, with which you can interact by touching them, and there it would work as well. So it doesn't detect whether you're using a mobile phone, because that's quite shaky. But it detects the capabilities of the device that is running your code. And it does that automatically. So if you didn't understand that in all detail, you don't need to. But if you're looking into the source code of the library, then you'll find it's not too hard.
I love that you called it auto magic, because that's exactly the way that I think of it as well. So we've talked about the visualization side of it. We understand now that there's certain actions that we can do. There's detections or things that we can detect that the user is trying to do, and then create an action based on that. What about the analysis functionality of it? Before we talked a little bit about editing, is there any sort of like measuring tools? Can we do any sort of in-depth analysis in an Openlayers client?
Well, it depends on how you define in-depth, but there are very basic ones like the measurement that you have already mentioned. So you can draw lines and measure their distance, and there are utility functions to help you also calculating whether this pixel difference that you got from there do mean. So how many meters are the 2 points of some line are apart from each other? That's one thing. There's also, when it comes, for example, to editing, there's the way of snapping one vector to another. But I told you already that Openlayers is very good at concentrating on what it is good at. And the analysis part isn't the thing that we have concentrated the most on. There's some basic functionality built into it, but it plays very well with all the other geospatial JavaScript libraries that excel here. But there's one exception to it, which many people do not know about. We already talked about rasters, and there's something in Openlayers that gives you the possibility to analyze raster data that you are seeing. So there's an online example that makes it possible to move some slider on the page and to let the seawater level rise, and then you can see where the water would be if the sea level would rise by, let's say, 15 centimeters, and how many or which areas of land would be covered then by water. There's another very great example that shows the basic capabilities or the building blocks to create your own analysis functions. And that's also an example where the vegetation greenness index is being calculated on some arbitrary raster source. I think that thing just loads in Bing tiles, so basically aerial images, and it has some small formula built into it how to calculate the greenness of one spot of the earth. So you move your mouse over the map, and the greenness is being calculated on the fly, and there's some playing around with thresholds. To be honest, this is these are examples. The last two are examples, but it shows that the basic building blocks are there inside of Openlayers to produce basically all sorts of analysis that you can think of, both when it comes to vector data. So there's a way of accessing all the features and to cluster them and to measure distances. But there's also a way of accessing raw pixel data of sources when they allow it, so that you can either analyze it or produce modeling ideas onto your map.
What I understood there is that there's a lot of opportunity to extend what's already there. So we have the building blocks, and then it's kind of up to us as the programmer to decide how we're going to use these building blocks. You mentioned that Openlayers plays nicely with different libraries, and earlier in the conversation we talked about this idea that libraries are becoming more and more specialized. They do one thing really, really well. Is there any particularly interesting libraries that you would like to sort of mention that work really well with Openlayers?
Well, there's two things that I would like to mention. So since Openlayers is built in JavaScript, and it's built in the way that JavaScript should be built when it comes to libraries. So it's built in a way that it can play with basically all the modules that you can, for example, find on NPM. And that's a bazillion of modules out there that don't all have some geo content or relation, but you can basically play with all of them. Coming back to Geo, there are some of this bazillion libraries I have been using for some time, and they are really, really great. So one is Turf.js, and the other one is JSTS. The latter one is basically a part of the Java topology suite. So it gives you a bunch of ways of, like buffering points. Let's say you have 2 points, you buffer them each by, let's say, 10 kilometers. Then you calculate the intersection of those now polygons. And then you take this intersection and you rotate it around. And then you see how big is the area covered or something like that. So it does the standard vector analysis parts very, very well, and it plays great with Openlayers. But there are also a lot of very, very small libraries out there. For example, there's one library that I know of that's called Arc.js. I'm not even sure whether it's that highly maintained anymore, but it's a very small library that calculates great circles. So you give it 2 points, basically, San Francisco and Berlin, and it calculates some great arc how you would basically fly there. And there's also a great example of how Openlayers and ArcGIS work together on the official examples page. And these is just, like some of them that you can use to create stunning applications with a geographical part, where Openlayers does some parts, some other library does some other parts, and all together you are able to create really, really great applications.
Now, when we talk about doing some of those analysis there, are we just assuming that we're dealing with 2D data, or is it possible to use 3D data as well in Openlayers?
Well, all vector data stuff in Openlayers is 3-dimensional by design. And back when we started, so right now we're at Openlayers version 6 something. Back when we still had Openlayers 2, so that was in the old ages, we would only know about 2 dimensions. And when we started on writing Openlayers 3, which was a very big change for the library, we created all the basic building blocks when it comes to vector data with 3 dimensions in our head, basically arbitrary dimensions. So when you have some measurement on some point in space. So yes, that can be done. When it comes to displaying 3D data, well, there's more dedicated libraries for that. For example, Cesium can be thought of. But I'm not sure whether this isn't something that we might be concentrating on in the, let's call it near to mid distant future. So because the 3rd dimension, of course, is still very real. And if you give Openlayers 3D data, it probably won't break but it also will probably not produce the 3D map that you would think of by default. But it plays, as I said, well with, for example, cesium together, so you can then use that to produce awesome 3D maps. What I'm guessing, I cannot dictate it or something, or and also I don't have any more details on how the future will shape out. But there is a chance that 3D data might become more of a place directly supported also when it comes to visualization directly in Openlayers. But I'm not 100% sure.
If we just do a bit of a recap here, we've got this visualization capacity here, like built into Openlayers, of course. It takes care of coordinate systems. It understands how to stack data. We have a lot of actions available to us, so it's a very interactive library. We have certain analysis that we can do, and we can extend it with these other libraries. Would you consider Openlayers, or say JavaScript in general, to be a geospatial language?
Well, it can be used to solve geospatial questions, but I wouldn't call, well, JavaScript is a general purpose language. It's I said it earlier, it's really grown up. It can be used to build really every application that can be thought of. There's even a law named to it. I think the guy that created Stack Overflow, I think it's Edward. He had that's Edward's law, and he stated, let's say back in 2000 and let's say 9, he said every application that can be built in JavaScript will eventually be built in JavaScript. So yes, JavaScript can be used to build, well, that's my opinion, to build basically any application. I wouldn't say it's naturally the best choice for all the applications. And coming back to the original question, for geospatial parts or questions, JavaScript provides a vast amount of libraries that play very well with each other. Not only Openlayers plays well with, let's say, JSTS, but also JSTS plays well with, let's say, ArcGIS. So yes, it's very well suited for geographic questions. When it comes to displaying stuff in the web, well, the web is the future of programming still, I think. So a lot of things have moved into the web, and the web is built upon HTML, and HTML has one super first class programming language, and this is JavaScript. So I think it's a very good fit to answer geographic questions when they come to the web with JavaScript. So yes, so that was the long answer, of course. The short answer is yes.
I think you did a really great job answering that question. I realized now that it was perhaps a little bit unfair. It was perhaps a little bit sort of general. But I guess what I'm sort of building towards is that if I agree with you. I think that the future of the web, or the future of geospatial is the web. I mean, we're doing so much more. It's the way that we deliver data to people, en masse. That this is how we're doing it, is through the web. And it seems to me that it's really interesting that there's so much focus when we think about geospatial programming languages, or languages that we can use to do geospatial analysis with. We often think about Python, we think about R, perhaps Java, C#, those kind of things. And it feels like JavaScript sort of gets left out a little bit. Why do you think that might be?
Well, that's an awesome question. So why is JavaScript the odd kid? I don't know. So it probably has some sort of historical reasons. Spatial is special and all that stuff. It's still the new kid around. It's probably the same age as Python, but and don't ask me whether it is. But well, Python has a super academic touch to it. It's a great programming language, of course. In academia, it's very often used, and it's great for questions being answered there. But it also has, of course, other ways that it does. Then there's the big applications or programs that are existing basically since ever, and they are written with older languages often, let's say C or something. And they are for a good reason. Well, for many good reasons. First of all, of course, because there weren't that many choices probably at the time. And C, for example, was a very good choice for many of the things. And because the processing that has to happen when it comes to geospatial data is very extensive. So it's a good choice to be next to the machine, let's call it like that. But of course, it has a high entry barrier, let's say. So I told you about my background, and I think I wouldn't have started programming if I had been thrown into some company doing C# or C, because the learning barrier is a bit higher. That's my opinion or my thoughts. While the learning barrier for JavaScript is basically non-existing, because you simply you hit one thing on your keyboard on any web page, and then you can type in some JavaScript on the right hand side in the console, for example, and you're already programming. And coming back to geospatial is of course very cool for programming at all, because you see something interesting every time that you program with it. So of course you can be a great programmer and only interact with databases or do analysis of like crunching numbers. That's great, and that's okay. But with geospatial, of course, you get a visual feedback of stuff you're doing. You can see maps, you can see diagrams, you can see modeling results, which is of course awesome. So bringing that together, that it makes fun to program on stuff that you can actually see, and that has a real world thing that you can even explain to your mom and dad. Combining that with a very low barrier of learning JavaScript, I think it's a good choice to start with and to excel later on. I hope that answers that question.
Yeah. Again, I think you're doing an amazing job of answering these questions. So given that we kind of agree that the web is where a lot of action is going to be happening in terms of geospatial data in the future, so going forward, I mean, I think we can all see that we're getting more and more data, and perhaps other languages are better suited to crunch sort of through huge amounts of data. But we also need to do something with that data. We need to show probably somebody the results of what we're doing. And if that's happening on the web, JavaScript seems like a really, really good option. Would you sort of encourage people to learn JavaScript then?
Oh yes, I would absolutely do that. I think the future of JavaScript is very bright. As I said, it's super easy to learn. It's not that easy to master, to be honest. So you get a very easy start with JavaScript. In order to take the best out of it and to produce very easy reusable code, you have to put in more. But you are getting well rewarded, I think. And this is not to be understood wrongly. I totally think that there are a ton of languages out there which have all pros and cons, as does JavaScript, of course. I think it's just a very good starting point, and also it's a very good choice for future candidates, because I'm pretty sure JavaScript will stay for a long time, and it will, of course, evolve. There's things like TypeScript. I really love TypeScript, which is basically a superset of JavaScript. So it has everything that JavaScript has, but it has something on top of it. It has great support from editors. It's easy to learn. There's a ton of resources out there. You get very quick feedback. The building around JavaScript is awesome. So if you decide on becoming a programmer, I know that Java programming has gotten like really, 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 really cool in the last decade. But, JavaScript has it all. It has, like instant builds. It has hot reloading when you do just one code line change and everything rebuilds. But of course, it doesn't only have, like the things that are cool. It also has some issues which need to be addressed sooner or later. So, for example, that many modules come with a bunch of problems, of course. So there's this famous thing when somebody does npm install, which is please resolve all my dependencies of my current project, and then the disk gets full because all the tiny libraries add up to, let's say, 800 megabytes of JavaScript. That is of course cool to like use a lot of small libraries, but you can also easily lose your way in that. So all in all, I would say it's a very wise choice to learn JavaScript. It's also very wise for programmers to not concentrate on any language or on only one language at all, because they all have different areas where they shine and other areas where they work but don't shine, and other areas where they say, yeah, you can do it, but it's probably the wrong choice to do it with that programming language. It's a famous interviewing question: what's your favorite programming language? To which there is no real answer. But if someone says, yeah, it depends, but I'm most familiar with that means he has thought of like programming and solving stuff with that. And other people that say, I do everything with JavaScript, that's okay, but then you probably haven't thought at all.
Yeah, I'm totally against the idea of being married to any one particular tool. I think, there's always going to be the right tool for the job, and that might not necessarily be JavaScript, that might not necessarily be QGIS or ArcGIS, but we can take our knowledge and apply it to different tools. At least that's what I'm hoping that where we're going as a geospatial community. If I wanted to get out there and get started with JavaScript and Openlayers today, do I need a server? Do I need to run a huge sort of environment just to get going?
No, you don't. Well, in order to get started, you basically just need your browser. And a browser, every computer has a browser. So you basically need nothing at all. So you just open some page somewhere, then you hit F12. That's that famous key on your keyboard that opens up the console in any browser that I know of. And then you get some small blinking cursor, and then you can put in JavaScript commands there, and they get executed on that web page. But very soon you'll learn I want to have a bit better programming environment. And then you'll be happy again because the programming environment around JavaScript is really, really cool. There are a ton of nice editors or IDEs. Well, I currently recommend Visual Studio Code. That's a very nice thing, which helps you with code completion. It also helps you with, like committing stuff to Git. But, these are already advanced things that you have to tackle, but sooner or later you will want to do it. Otherwise, you will be just playing around and not, become a real programmer. JavaScript is very easy to start with. Well, both to understand and also, like the technical stuff around. You don't need any compiler at first. Well, later on you'll probably want one. You don't need to read some big book. There's probably 5-minute JavaScript courses out there, and they will help you get the job done. But then you'll get thirsty, of course, for more professional JavaScript. Oh, I said that earlier. It had that in the beginning, that toy language feeling around it, JavaScript. And that's probably because it's so easy to start with it. It's way easier than to, write your first C program, for example. But that also leads to people doing only, like small tasks with it and not creating the next operating system with it. But you can, of course, do it.
But I think that's where it starts, right? It starts with those early and easy successes where people sort of get their feet wet, realize, yes, I can do this. And like you were saying, it leaves you thirsting for more. But I think those small steps is the way to learn something like JavaScript and Openlayers. So again, thinking about getting started here, you mentioned a few tools that we could use and a few different ways we could get started. I know there is a ton of really cool examples on Openlayers. If you go there, search for openlayers.examples, then you can find these examples and it shows the code as well. Is there any sort of common mistakes that you see when people are using Openlayers that we could perhaps avoid when we get started?
Well, there are some common mistakes. I actually did a talk once about that. Right now, when you use Openlayers in the intended way, that is a bit more involved than just opening F12 and hitting something in there. But if you have to have some sort of a building environment around you, which is totally familiar to everybody working with JavaScript, to be honest, but to complete newbies, it's probably a bit involved, and they'll start out with the full build. That's what we call the full build. So as I said, Openlayers has a ton of functionality, visualization, smaller parts analysis, and also like interactions with the data that you have. Of course, this adds up. So I don't even know how big the full build is. It's probably roughly, let's say, 2 or 3 megabytes, which is big. And in order to just create a map that has OpenStreetMap and some vector data, which let's say 8 out of 10 maps on the map need, they probably don't need too much more. You don't need to load 3 megabytes of Openlayers. So this is the same thing. Basically, it's the same story that we had earlier. So it's very easy to get started. So you load the Openlayers library into it and the CSS, and then you get started. But the map that you produce will look great, but it will load 5 seconds on your mobile device, and then people are already gone again from your web page, and they will never ever use your web page. If you invest a little bit more time, as I said, it's very easy to do so because Openlayers plays by the rules that are currently played by everybody in the JavaScript world. Then you can get a very tiny, small JavaScript build that contains all the parts of Openlayers that you need for your application, but it needs a bit of, like setup. That's one thing that many people do wrong. And of course, the thing that everybody does wrong, including all Openlayers core developers, they mix up LON and LUT. So I still have to find some developer that hasn't done this on a regular basis. So these are two common, let's call them, well, the other one is something that it's an error that cannot really be circumvented, and the first one can be easily circumvented. I would say these are some common errors, or pitfalls.
Mark, I really want to thank you for your time. I know it's late in the evening now, so I really appreciate your time. I've enjoyed learning more about Openlayers. It's something I've played with myself, and I think that the library is absolutely fantastic. So thank you very much for all your work that you've put into extending and maintaining the library. It's much appreciated. Before I let you go, where can the listeners go if they want to reach out to you, if they want to learn more about Openlayers? Is there somewhere specific where we could send them?
Well, first of all, thank you for having me, and that thanks that you have addressed to, let's say, me. I would like to reach out to everybody that has contributed to Openlayers, because there's a big community going around, and my code contributions are, comparably small to other people being way more involved in the actual coding. So thanks from my side to all the contributors, small or big, and the people around it. Coming back to the question of where would people go to reach out. So openlayers.org, that's the main webpage. From there on, everything is linked. As you said, there's I think nearly 300 examples showing all the different aspects of Openlayers. There's a very detailed API documentation for people that want to start programming with it, because you need to know properties and methods that exist on the small building blocks of Openlayers. And for questions with regard to Openlayers, it's a very good idea to visit Stack Overflow, give it the tag Openlayers, and people will reach out. And of course, there's also the traditional mailing lists to get more involved, where you can decide or discuss with people around approaches of solving your specific problems. So these are all linked from the openlayers.org website, and I would really, really love to see more of you people come there. And one final tip is probably also something that people sometimes get wrong. So Openlayers is big and huge, and it can do a lot of stuff. But I'm pretty sure that you are totally able to understand what it does. Just look at the source code. It's all there on GitHub. Look into the sources. Try to find something that you might want to address and enhance. Open an issue or send a pull request. We really, really appreciate anybody trying to help us make the best JavaScript library out there for mapping.
Thanks again, Mark. Really appreciate your time.
Thank you, Daniel.
Thanks very much for tuning in again this week. I hope you enjoyed this conversation with Mark about Openlayers and JavaScript. And I think if you're looking to learn a language, have a look at JavaScript. I'll put some links in the show notes so you can click through to the Openlayers website and check it out for yourself. As always, you're more than welcome to reach out to me for whatever reason. You can find me on social media. You can go to our website, mapscaping.com, and get a hold of me there. I would really love to hear from you. Okay, that's it from me. We'll talk again next week. Bye.